If it bisects, it's called the midsegment, and whatever that smaller one is, it's 2x for the other. Have you seen anything like that in class?
I think wait, I think so.
Okay, so let me give you two problems here to see if you got it, and then work on the harder ones, which have a little bit of algebra in them. Here are two problems for you to think about. I want you to find kj in this one, and then ik in this other here.
Fine. You want me to find KJ?
Yep.
Wait, so is it wait, how do you do this? How do you solve it? There's no like
Let's go back up and look here. I gave you a sample problem, and I gave you kind of the reference here. Tell me what you see.
8,
Okay, and what's the other number?
16.
What is their relationship? How could you
They're
go from one to the other?
parallel.
Yes, they are, but that's not what we're looking for here. We're talking about side lengths. What's the relationship between the numbers? Like, how do you go from one to the other, the smaller to the larger, larger to the smaller?
They're
I'm trying to show you that over here. Like, if one is x, the other is 2x.
yeah. It's what is it called? I don't know.
Okay, well, what is two in front? What's another word for two?
Wait,
All
one
right.
more time.
Yeah, I'm not trying to make this difficult. I'm just looking for the word like double or cut in
Oh,
half
double.
or twice, something, two times. So you go from the smaller 8 to the larger, you're multiplying by 2. You go to the other one, you're dividing by 2. That's it.
Okay.
So here's two problems, one of each type.
18 and there's only one number for number 5.
That's right. You have to find k to j. So you have to
Oh,
use
is
that
it so
relationship.
it's 9.
It is 9, yes. And the
And
other
then the
one over
other one
here
is uh 5. So it's 10. K and
is
I.
10.
Yeah.
Very good. Now, this is the most important part. Is writing the segment relationship. So AC is the bigger one, equals 2 times the smaller one. Bigger equals 2 times the smaller. On the right here, again, you want to start with the larger one. If you prefer larger instead of bigger, it doesn't matter to me. 2 times the smaller SR. Is that clear?
Yeah.
Okay, that's how we're solving these. So I'm going to give you some harder problems here. You have to use this relationship to solve them. They're not that much harder, but you're gonna have to write something down. Okay, so here's your new problem. Which is the larger one? Which is the larger segment?
Um Y and W.
YW equals 2 times which segment?
Q and R.
QR. Do you have a variable expression for Y to W?
X
A
plus 9.
plus, okay,
9.
and how about for QR?
2x minus 3.
Okay, so here is the equation that you have to solve. So now we're back to algebra. Will you try solving this for me, please?
Oh yeah. X, okay. Calculator. Uh so x plus 9, 2, so 4x minus -6 or +6. Wait, a -6, yeah. 4x. I need a pencil and paper. Hold on.
Yeah,
Yeah,
why
what?
don't you grab something? You'll be solving a few equations here going forward.
Two x minus 2 x minus 6 x plus 9 equals plus 6 plus 6 15x plus 4x plus x minus x is 15 equals 10x. X equals 3.
Okay. So here's the check. We're going to put that number back in. 3 plus 9 is 12. 2 times 3 is 6. Minus 3 is 3. That does not work. That does not satisfy the doubling relationship. So let's take a look at what you did to solve it. Did you multiply both by 2 on the right?
Yeah.
Did you get something like this?
Yeah.
Okay. So you're going to add 6 to both sides. You're going to subtract x from both sides. Lots of ways to do this, but you should get it down to 15 equals 3x. Probably
Yeah.
where the error occurred. What is the correct value of x?
Oh, it's 5. Oh,
It's 5.
okay.
So
Yeah.
that changes everything. 14 and 7. Does that work? Yes. So where was the error? Was it in dividing, or did
Oh,
you have
no.
different?
I did 15 divided by 3, and then I don't
Okay.
know. I got it wrong and thought of 15
All
divided
right. Okay. So here's a similar problem. Which is the longest segment or largest segment or biggest one?
by 3x minus 8 or SQ.
SQ equals 2 times what segment?
X plus 2.
ZY. Yep. Now, you do not have to write this. I'm just sort of trying to reinforce, hey, like it might be a good idea to do this so that when I give you a more complicated problem, you know where to start. And you're right, it's 3x minus 8. Make sure you put the other one in parentheses. Okay, so you're up here. Try solving this. And
3x minus 8 equals 2x plus 2. Okay. 2x plus 4. Yeah. 3x minus 8. Oh my god, wait. X equals 12.
all right, let's take a look here. 12 plus 2 is 14. 3 times 12 is 36 minus 8 is 28. Is that double or half? Does that work out?
Yeah.
Okay, yes, it does. Any questions before I put one in front of you to solve totally on your own? No help from me.
No.
Okay. All right. There is a piece of information you do not need. You can ignore that. Go ahead and work this one out for us, please.
X plus 6 equals, yeah, equals 2x minus 3. Okay. 2x minus 6 equals x plus 6. And then plus 6 plus 12x plus 12 equals 2x minus x 12 equals x. Is it 12? Oh, wait. Substitute this. So 12 minus 3 is 9 and 18. Yeah.
What I really like about you, Blaize, is you're assertive. You're like, Roger, try it, which is exactly what I was going to do. See if it works. And that's great. Now, keep in mind, X is not related to the lengths of these. Like it's just like a number. It's not important. What's important is when you put it back in to the problem there. And that may resonate with you when I give you this last problem for us to try, for you to try before we move on to something else. But yeah, one more. So go ahead and take a look at this and let me know what you come up with.
Okay, so x plus 29 equals 2 times x plus 19. Hold on, let me grab a calculator. Actually, I can do this with that one. X plus 29 equals 2x plus 2018, 38. Yeah. Yep. And then minus 29 minus 29. Oh, it's gonna be x minus x, so 29 equals 1x plus 38 minus 38. Negative. Is it negative 9? Here, I'll just check. Negative 9 plus.
Yeah, that's what I was referring to. Like, you're a little uncertainty. You're like, well, it could be negative. Well, yeah, it can be because it's the actual results here that you care about.
Plus 29. Wait. Negative 9. Oh, it's negative 9, yeah.
It is. Very good. Any questions on what we just did there?
No.
Okay, so there's two types of problems with triangles and circles. One is when the circle is inscribed, and then one is when it's circumscribed. Might be important to know the difference. I don't know. Something like that. So that's kind of generally what you're doing here. There's a lot of problems that you're about to see. One of them is related to right triangles. Did you guys talk about how to find the third side of a right triangle? Yes, no, maybe.
One more time.
Did you talk about how to find the third side of a right triangle?
Um, I don't remember.
Okay, let me show you, and then you can tell me if you remember. This is A, this is B, this is C. A squared plus B squared equals C squared. A and
Oh
B
yeah,
are considered the
Pythagorean theorem.
legs. Yes, the legs come out from the 90. You have two legs. Well, I've never seen you, but I assume you have two legs, and they come out from your waist, hips, whatever, and the hypotenuse is across from the 90. So the reason I'm saying all that is because I can reorient the triangle, and you can't just use your opinion about where the C is. A and B are the legs, C is the hypotenuse. Is that okay? Any
Yeah.
questions on that? Thoughts on that?
Yeah.
All right, so let me have you try to find the third side of this triangle. Let's say it's 5, 12, and C. A and B, they're interchangeable. You know, if you prefer A down here and B up here, that's okay. Doesn't matter to me. You'll still get the same answer. I'd like you to try solving this for C. You have to put 5 in for A, 12 in for B, square both, add them together, undo the square with the square root. Let me know what you come up with.
5 squared equals C squared. And 12 squared 144 plus squared 25 equals 144 plus 1. Wait, is it 100? Wait, no. Do I have to square the answer of?
You have to square root the answer. So 5 squared plus 12 squared equals C squared. 25 plus 144 is
It's 169
169
squared.
square rooted. Square root, that symbol there.
So it would be, oh, square rooted?
Yes, you undo a square with a square root. You undo a square root
Oh,
with a square.
oh. 44 plus 25. Then, oh, 13.
It is 13. Very good. Let's try another one here. All right. Can you find C for us, please?
8 plus 15 from, let's see. 8 root 64 plus 17.
It is 17. Very good. So we're doing all the nice ones. Now we're gonna do a backwards problem. So let's say I give you the hypotenuse this time. I tell you that this is 8 and this is 10. We'll call that B. You're still going to use A squared plus B squared equals C squared, A, B, and C. But this time you have to square the two other numbers that you have and then move this 8 squared to the other side of the equation. Does that look familiar to you from class?
Oh. Oh no, we didn't go over Pythagorean theorem again in class.
Okay. Well, I'll walk you through this one. 64 plus B squared equals 100. You subtract 64 from both sides
Oh, you
and you
just
get
solved it
B
like a
squared.
algebra problem.
Exactly.
Uh, B squared. What?
What is the value of B?
Oh, 36. Wait. Oh wait, no, I pressed the wrong button. Is it 6?
Yes. All right, so one more for you to try before we close out today. Let's go 7 and 25. Call that A. This is B, this is C.
Plus A squared equals 25 squared. Okay. 7 squared plus 25. Equals this. And then take the square root of this. Wait, oh my god, hold on. Why am I stupid? So wait, 7 squared. Four. Wait, what did I do wrong?
All right, we are running out of time here. It is 24. Make sure you subtract that 49 from both sides.
Oh,
Okay,
okay.
we'll work on this more next time if needed, but good job today overall.